name is Guðbjörg, and today I'm going to be comparing some methods. First of all, I'm going to start with the Kirchhoff method. As you see, I've already written it down just to save some time. This is a pretty basic circuit with two independent sources, one voltage and one current, and two resistors. So I'm going to start with using the Kirchhoff's current law, which is pretty basic, just the currents combine here, and the Kirchhoff voltage law. Then I'm going to combine these two into here and find the current in branch 2 and the current in branch 1. As you can see, the current in branch 3, it's just 2 amps. Then I'm going to use this to calculate the voltage in node A. And I use current 1 to calculate the voltage drop over over branch 1. And so the total node voltage at node A is just 8 volts minus the voltage drop over here. And that is the total 6.75. Next I'm going to be using the node voltage method, and we're going to see what I get there. So as you can see, now we have the same circuit, but I've changed the currents. They're going, especially this current, it's going in the other direction. And now I just combined the currents, and they're all going away from node A, so they're all equal to 0. Then I use Ohm's law, which is this, but we're finding the currents here, so I'm going to be rewriting that as V over R. And I'm going to use this over here, and here we're going to go from node A to 8 voltage over the 5 resistor, and just the same here in branch 2. And in branch 3 we have a current, but it's going the other way, so I'm going to add a minus sign here. And it's just basic algebra, and get 6.75 voltage, which is the same as in the previous example. And then I'm going to calculate the currents, and I use this, which is that one here, and I've just plugged in VA, and I calculate the current, and it's a minus sign because it's going in the other direction, so it's not going this way, it's going that way. And then I just calculate I2, and this is all the same as in the previous example, as you can see. And next I'm going to be using superposition, which is a little bit more complicated than this, but in my opinion, I think this is the easiest way to be using, to be finding especially the node voltage. So now I'm going to be using the superposition method, and as you can see, I've drawn two circuits. And in the first one, I replaced the current source with an infinite resistor, which is just an open circuit. And then in the second one, I replaced the voltage source with a resistor with 0 resistance. And that's just a short circuit. So now I'm going to be calculating the node at voltage A. And that's going to be VA minus 8 over 5, and it's going to be plus VA minus 0 over the 3 resistor, and going here, and no current is going to go through here, so it's just going to be equal at 0. And then I'm going to be it's going to be 8 over 15 VA, and that's going to be 8 over 5, and that's going to give me VA is equal to 3 volts. And I'm going to be calculating the currents, and that's just basically it's I1 equal to VA minus 8, that's going to be 5, and that's going to be minus 1 ampere. And the same for current 2, that's going to be VA times 3. Is going to be 1 ampere. So now I've got these three for the circuit, but now I have to calculate the other circuit. And that's just going to be the same as VA minus 0, because there's no voltage source. that's over 5, and that's plus VA minus 0 over 3. And that's going to be plus or minus 2 ampere because it's going the other way. And that's going to be equal to 0. And that's going to give us, just basic algebra is going to give us 3.75 volts. Now I'm going to calculate the I1 current. And that's just basically VA over 5, which is this one. And that's 0.75. And then I'm going to calculate I2. That's VA over 3. It's that one, and that's going to give us 1.25. Yeah, it's also like this. And because it's a linear circuit, I can put everything together. Because it's a linear circuit is composed of linear elements, for example, resistors. An example of non-linear element is, for example, a diode or a transistor. And now I can put all these together, and that's VA is then equal to 3 plus 3, that's 6.75 volts. And that's I1, that's 0.25 amps. And I2, going to get that the same way, that's 2.25 amps. And as you can see, we get the same results for all the methods. And I think the superposition, you can see it's pretty much the longest way to do this. But it's good to use superposition if you have many sources. But in this case, 2 sources is not that much, and it just complicates the circuit. Then the reason why I'm not using the mass current method, or showing this in this video, is because we have 2 mesh currents, one here and one here, and only 1 node. So when the mesh currents are more than the node, and you're maybe going to find the node voltage, it's going to be harder. If you have fewer meshes and more nodes, and you're going to find the mesh current, I would recommend using the mesh current method. So thank you for watching the video. Goodbye.